Hello everybody, welcome. It is Wednesday, April 29th. We are going to be going over some problems today. So we're looking at the number of text messages that 8 students received on Monday. Sorry, we're doing MAD again, should have mentioned that. We're doing MAD one more time today. Excuse me. The number of text messages that 8 students received on a Monday is as follows. And we have the following here. Student 1 received 42, student 2 received 56, student 3 received 35, and so on and so forth. Part A asks us, what is the mean number of text messages that the students received on Monday? So to find the mean, we're going to add together all of these values. That's going to be 42 plus 56 plus 35, and so on and so forth. Not going to do all of them there. Over, and there's going to be 8 students there. As we're told, there's going to be 8 students there. So we add all these together. We're going to get 424. Total text messages were sent on Monday, or received, divided by 8. And we're going to get the mean, or the average number of texts received by students on Monday is going to be 53. That means that on average, we have students receiving 53 texts. Some of them are going to receive more, some are going to receive less, but on average, it's going to be 53. If we made a little dot plot here, if we had our average right here, we would have, say, 42 here, we would have 56 up here, we'd have 70 all the way up here, stuff like that. Next, we're going to find the MAD, or the mean absolute deviation from our average here. So we want to figure out what the average distance from the mean is going to be, and that's going to tell us how far apart our data is spread. So to find the MAD, our first thing we need to find the mean first, so that was our first step. Our second step is to find the distance from each point to the mean. We need to find the distance to the mean. To do that, we're going to take the absolute value of each of our points, 42, say take this first one here. We're going to subtract away from that our mean value. So we're going to take the absolute value there because distance we want to always have as a positive. We want to have a positive distance there. 42 minus 53 is going to give us negative 11. But we're taking the absolute value of that, so that gives us just 11. Our next point, 2, is going to be 56 minus 53, absolute value of that. That's just going to give us 3. Our third point is 35 minus 53. Take the absolute value of that. It's going to be absolute value of negative 18, which just gives us 18. Our fourth point is going to be 70 minus 53. That's going to give us 17. We have 56 minus 53. That gives us 3. 50 minus 53. That also is going to give us 3. Do these over here. We're going to have 65 minus 53. That's going to give us, where is that, 12. And then we're going to have 50 minus 53 again. That's going to give us 3. It's going to give us 3 one more time. Awesome. So this here is each one of these is going to be an individual distance. I'm going to put this in blue. It's going to be an individual distance from the point to the mean there. So this one's going to be 11. At 56, it's going to be 3. And we're going to be adding up all of these distances and then dividing it by the number of distances that there are to find the average distance from a point on our dot plot to the center. So for 3, we're going to find our MAD. And to find that, what we're going to do is we're going to add each of these up. So we're going to do 11 plus 3 plus 18 plus 17 plus 3 plus 3 plus 12 plus 3. Then we're going to divide that by the number of points that we have. So we're going to add all these up. That's going to give us 70 over 8. It's going to give us 8.75. So that means that on average, each one of these points is, or on average, the points are 8.75 texts away from the mean. On average, we have 8.75 texts away from the mean. Awesome. Question number 2. So Jula and Javier both have a mean score of 79 for the year. The MAD for Sanjula's quiz is 6.6, and the MAD for Javier's quiz is 1.2. Which student is a better math student and why? Let's start with that one. For this one, it's going to really be, I said Javier is a better math student because their MAD is lower. Remember, a lower MAD means we are more consistent. When the MAD is low, that means that our data is more tightly packed together, so they're going to be more consistent. So I said Javier is more consistent, so he's a better student, but I would accept explanations for either one of them. More consistent. This one, I'm not going to put too much weight into this one. As long as you understand that a lower MAD means that we are more consistent. Lower MAD is more consistent. Part B, though, if Sanjula's mean score was 85 and Javier's mean score was 79, and the two students had the same MAD of 2.3, would your answer to Part A change at all, and why? Well, our answer is definitely going to change. It's going to be Sanjula is going to be our answer there. She has a higher mean score than Javier, and they have the same consistency, so Sanjula, higher mean, and they are just as consistent. And they're going to be just as consistent. Awesome. So for this one, I want you to pause the video and answer the question, and then I want you to resume the video when you have finished answering the question. I really want you to pause the video. I feel like some of us are just blowing through it here. Alright, I'm assuming we've unpaused the video now, and this question asks us, the table below shows the average monthly temperatures for two cities, January and August. So we have Brownsville, Texas, and Caribou, Maine. So for Brownsville, our average that you should have calculated is going to be 74.75. We'll just do all the Brownsville stuff first. The MAD for Brownsville, they should have calculated, was 8.5625. And then we're going to go look at, what's it called, Caribou, Maine. Caribou, Maine, the average temperature there was 40.625, significantly colder outside. 0.625. And the MAD for Caribou, we can already tell the MAD is going to be pretty high because we have a crazy wide variation here. We go from 9 to 12 to 25 to 38 to 51 to 61 to 66 to 68. That's a really wide spread there. So our MAD for our mean absolute deviation is going to be 19.625. So based on this, we can most definitely say that Brownsville is more consistent. We know that because the MAD is much lower than for Caribou, so therefore consistent. Therefore, it is going to have a more consistent temperatures. We have lower MAD for Brownsville, which means that it's going to be more consistent. Alrighty, we're going to do questions 4 and 5 on your own, then we're going to resume when you come back. Do these two on your own. This is a pause symbol for those that are familiar, pause symbol. And we're going to resume when you come back. Alright, I'm hoping you've done these two questions. Let's take a look at question number 4. Jeremiah and Jasmine are in a fight about who is a more consistent test taker in math. Jeremiah says he is a better test taker because the MAD for his test scores is 22.5. So we have Jeremiah is going to be 22.5 MAD. And Jasmine has a MAD of 5.5. Which statement below matches your thinking? I go with Jeremiah. The higher the MAD, the higher the data. That is not correct. Not sure where he got that logic from. I agree with Jeremiah. The higher the MAD, the closer together, and therefore more consistent the data. No, Jeremiah. You have a higher MAD, that means you are less consistent. Remember, low MAD is more consistent. That also means that higher MAD is less consistent. So we're going to disagree with Jeremiah. It's going to be C. The higher the MAD, the more spread out, and therefore less consistent the data. It's going to be C for sure. And question number 5. This is my favorite one personally. 7 students weighed their backpacks and found that the mean weight was 18 pounds and the mean absolute deviation was 0 pounds. Part A. What does the mean and MAD tell you about the weights of the 7 backpacks? How do you know? Well, for MAD is 0, that means that we have no deviation whatsoever. That means that all of our backpacks are going to weigh the exact same thing. So we know that all backpacks are 18 pounds. So all are going to be 18 pounds. It's because our MAD is 0 and our average weight is 18. So that means that we're going to have 18 plus 18 plus 18 plus 18. We're going to divide that by 7. And so that means that our average is going to be 18 pounds. And if we had a dot plot to represent that, it would just be 7 dots, 3, 4, 5, 6, 7. It would just be 7 dots on our dot plot to represent the 7 weights of the backpack. That's going to be it for today. Thank you so much for coming and watching our video. Make sure you're in the class instead. Answer the classwork and homework. I really need you to do that. And feel free to come to my office hours later. Take care, everybody. I will see everybody tomorrow.